So it's like, you know, the bureaucrats, you know, take their time realizing that things move, things change. No, they would just say, oh, here's what you buy. That's good for you. It's basically a $3,000.
The only the difference between my board and the country room only in certain situations. I don't understand certain situations.
Well, it's I would agree that it's an overkill for what I do for now.
Okay,
But
so what you have to do for this assembly is, there's two nuts you're gonna have to draw. I'm gonna help you draw one of them, and I'm gonna let you guys draw the other one, okay? Instead of doing a castle nut and so forth, we're just drawing regular hex nuts, okay? To make it a little bit easier for you. One's gonna be a 5/8 nut, one will be a 1/2 inch nut. Does everyone understand where I'm getting those numbers from? The 5/8 is the bottom one. It goes on that one little shaft that holds that little U bracket up. That's 5/8, right? Okay. Okay. Are you okay with that? There's one, you know, this little bracket that goes like this here. Then there's a bolt here with a thread down here, right? This is a 5/8 right there, isn't it? Okay, so this one's a 5/8. Now, up here, the bolt that goes through here is a 1/2 inch, isn't it? So you have a 1/2 inch and a 5/8 bolt. So we're going to draw a 1/2 and 5/8 nut. Are you with me there? Everybody okay with that? Okay, so now, if you look at this sheet right here, so everyone should have this sheet. We're just going to kind of carry through with this sheet right here to draw a nut. Okay, which one do you want me to draw? The 5/8 or the 1/2 inch one? Because you guys get to draw the other one. 5/8. So we're going to draw this one down here, okay? We're going to draw the nut for that end of that shaft right there, okay? Okay, now, what we're going to be doing is we're going to make it easy, and we're going to be doing this first nut right there. Everyone see that nut right there? That's what we're going to be drawing right there. Do you have this, Caroline? Do you have this sheet? Okay.
yeah, I make sure it's here on Monday.
Okay. So that's the nut we're going to be drawing. Okay. So, in this one, it has the nut down here, you know. We have, then it has this hex head up here. Kind of like that, right? Okay, there's an inside circle here now that has a measurement on it. What's that measurement? Times what? D. Well, 1.5 times D is what that means, right? What do you think D stands for? Diameter. Exactly right. So, what's our diameter we're working with?
Oh.
5/8, isn't it? Does that make sense now to everybody? So what is 1.5 times 5/8? Someone tell me what that is. Work that on your calculator. And then we'll start drawing this.
5/8 being 0.875
0.625
times 1.5. What, 0.625?
0.625 is 5/8.
0.625.
What is it? Okay,
Yep,
0.9375. Okay, so we're gonna need that number to begin with. Now, the other number that we're going to need is how high is this nut right there? What's the measurement of that one? Okay, now be careful now. On here, what does it say the height of it? What do we multiply the diameter by? Uh-huh. 0.875 times D, right? You see that? Right there on the side, right there.
Right.
That gives me the height of it, doesn't it? Right. Right. Yeah, we're doing the nut. Okay. So in what you were saying now, if we were doing the head, then it would be the what is that? 0.67 times D, right? Is that okay now? Yeah. Okay, so what's 0.875 times D? What's that equal to? 0.546. That's close enough, isn't it? Okay, now we can actually start drawing this, okay? So let me turn the lights down so you can see here. In fact, you know what I think we'll do on this, if it's okay with everybody? Let's draw the top of the head, let's draw the bolt, and let's draw the nut underneath the bolt, and let's put some threads on it, just to review threads and everything. Is that okay? Does that make sense with everybody? Yeah, but does anyone need a review of how to do threads? I guess that's what I'm asking. Okay, so let's do it. So we'll draw like this hex up here, you know. Then we're going to draw a head here with the bolt here, and then we're going to draw another bolt down here, a nut down here. Does that make sense? See what I'm after now? Okay, let's do that. It's going to teach you a lot of new commands in AutoCAD. You see okay there? I brought my little light so I can actually see today. $1.50. And so, if it helps, you know, if anyone can't afford it, if you want one, let me know, and I'll let the department buy a couple of them. We have them around, you know, if you think you need one, you know. Okay. So what I'm going to think. So we're just going to draw this right over here, okay? So the first thing we're going to do is we're going to do the top part, that hexagon at the top. So what I want to do, and I don't think you guys have ever done this before, but we want to draw a hexagon. And do I want it inscribed or circumscribed around a circle with a diameter of 0.9375? Does that make sense? You see what we're drawing there? Who doesn't understand what we're drawing here? This hexagon we're drawing, and it's circumscribed around a circle with the diameter of that. Are you okay with that? Okay, let me show you how easy that is, and that's our starting point. Okay? So, let's go ahead now, and if you go under rectangle right there, you see polygon. So go to polygon. Everybody okay with polygon? Okay, hit polygon right here. And it says inner number of sides. So how many sides do we want? 6 then, right? We're going to 1, 2, 3, 4, 5. Yeah, we'll go with 6. Okay, so 6, enter, specify center point of polygon, just pick a point right there. Now it's asking you, do you want to inscribe or circumscribe about a circle? Which one do we want it? Circumscribed. What's the radius of the circle now? Now it's asking for the radius, okay? So what is 0.9375 divided by 2? First of all, what is 0.9375 equal to? Okay. Go 15 divided by 16. Tell me what you come up with. So that's equal to 15 sixteenths, right? What's half of 15 sixteenths? Now, don't make it hard. Don't make it hard. We were talking about this morning.
30 seconds.
No, yeah, 15, 30 seconds, right?
Oh, 15, 30 seconds.
That's half of 15 sixteenths, isn't it? Who doesn't understand that? Anybody? Are you good with that? Let me show you something.
Yeah, that's right.
If I have 1/2, what's half of 1/2? 1/4. What's half of 1/4?
Oh, yeah, no, but
1/8, right? What's half of 3/4? 3/8. What's half of 3/8? 3/16. What's half of 3/16? 30 seconds. So if we have 15 sixteenths, half of that is 15 30 seconds, right? Okay.
Thank God we don't have to deal with the difference between a dry ounce and a wet ounce, liquid ounce.
So the radius is 15 30 seconds. So 15/32. Guess what? There's your hex. Right there. That's the top of your nut. As simple as that. Okay? Okay, now we want to verify it though, don't we? Make sure we did it right. So if I go ahead, let me just go through a couple of things with you. When you have a hexagon like this, these flat sides right here are called flats. So if I gave a distance between my flats right here, it should equal 0.9375, correct?
Yes.
So let's add us a dimension to make sure that's right. So do a linear dimension now from here to here, 0.93. Now why is it 9375? Because of my precision, right? So if I were to change this number right here, excuse me. Let's see. Okay. You put it in 15 30 seconds for the radius. Now, is it asking for diameter or radius? Okay, see? Okay, specify radius of circle right there. I'm down here now. Okay, down 15, get rid of the app. Try that. There you go. Okay. Okay, so I'm just going to go ahead and put a home here, and I'm going to just change my precision here. Okay, so it's 0.9375, so it's exactly right. It's just kind of the precision that we have set, okay? Now, so again, that was just to verify. So what I did was modify. Oh, you got it. Good. Okay, Now, if you look at the top of a nut, what do you see going around the top of a bolt? I mean, there's a circle around there, right? Have you noticed that? So I need to draw me a circle now inside of this right here.
Outside.
How do I do that?
We can do 10, 10, whatever.
You bet. I can go tan, tan, tan right there. So circle, go to the down, the very bottom where it says tan, tan, tan. Just click tangent here, any three sides. And it'll draw you a circle inside of there. So as far as we're concerned with this drawing right here, we've drawn the top view right there. Okay, now we aren't going to draw the hidden lines for this bolt right now. We're just going to draw the top of the bolt. Is that okay with everybody? Okay, now, let's come down here. Is everyone's in this orientation? This is the orientation that we want it in right there. I don't want it rotated. Okay, what would this distance from here to here be now? Remember, this was across flats. This would be across what? Corners. Does that make sense? Okay, so now let's come in here and we're going to draw the top of that bolt right there, the head of the bolt. Is everyone okay with what I'm doing there? Okay, so now what I'm going to do is I'm going to draw me a line from here and turn on ortho. Come down here. So draw a line. Okay, then I'm going to draw me just a random horizontal line right there. That makes sense? Now, on the head now, what's the height of my head? Is that 0.67 times D? What's 0.67 times D?
6, 7,
0.41875. So it's offset 0.41875. Okay? And then just offset this line here. Okay, that's the head of the nut bolt right there. That's how high that bolt is. Does that make sense? See how I'm working through these numbers here? Okay. So what we're going to do is we're just going to kind of lay out all of our sizes first, then we'll go back and actually draw it. Is that okay? Okay, so what I'm going to do is I'm going to use my fillet command now with a radius of 0, and it's already 0, so I'm going to clean this up right here. So there's the head of my bolt right there. So offset that to 0.41875. Got it. You just both offset. Yep, you got it. Here. I think that line just come up or down from the back. Now trim that up. Now, right now you raise the 0. So click this line here. Click this line here. That line there. Spacebar. Click there, there. Spacebar. You pick this other line there. You didn't click that. Oops. Sorry. I click that line. Okay. So does everyone have this rectangle here now? Okay. Now, we have, it's a hexagon. It has 6 sides, right? So what we're going to do is we're going to project these lines down here now. And that gives us our division on that. Does that look like that head of that bolt now? We have to add some more things to it, but that gets us in the general area, right? Okay, so trim these up here now. Pick these 2 lines right here and trim it up. So just leave it like that for right now. I'll help you get the arcs on it and everything else in just a minute. Okay? Okay. Now, question, I'm gonna come down here with a bolt, and we're gonna make the length of it 3 inches long. So let's offset this line here down 3 inches. So offset 3 from here down. That's a long ways. Let's make it a 2-inch bolt, okay? It's only offset at 2 inches. Offset 2. Okay? There, that sounds better. Now, I've got to come down here now and draw how wide of a shaft here? 5/8. So draw a line now from the midpoint here down here. So how far am I going to offset at both sides? How far? 5 what? 5/16. You bet. So offset 5/16. Okay. Now I'm going to do my fillet thing here. Okay. Now, we're going to thread 1 inch of this. So let's offset it 1 inch. Okay. So this much has to be threaded of our bolt. We good so far? Am I going too fast? Okay.
How much did you want us to offset from the center?
5/16 because it's a 5/8 bolt.
Okay.
And 5/16 is half, so we just go half on each side. Okay. Now you're gonna like how we get the layout for the nut here. It's gonna be very, very simple. The layout of the nut, size of the nut, is the same as the size of the head. So I'm just gonna copy that, pull him down about right there. That make sense?
But it's a little taller.
Right, right. So I'm going to erase one of these sides here, and then I'm going to offset.
What did you pick as a reference point, Mike? For the copy?
Point out here.
Oh, okay, and then.
As long as my ortho's on.
Right, and let the ortho.
Right, exactly. Erase one of the lines because this has to be 0.546, doesn't it? That's what we got before because it's this right here, 0.875 times D now. Oh, okay, you got it. Okay. Okay, so let's offset that 0.546. Okay, and extend all these lines down here. Just like that. So we have our layout, and we're just going to do exactly what the sheet says to do to get the rest of it right there. But you saw how I got my layout, right? So whenever you do fasteners, what's the most critical thing you know? There's 2 things, right? The first number, which is always the what? Major diameter, right? What's the second number? The number of threads per inch. So like a -13 would be a 1/2 inch major diameter, 13 threads per inch, right? And we can figure the pinch, angle, the depth of those, everything from those 2 numbers, can't we? So you need to know those 2 numbers. And on this one, all we had to worry about is the diameter, which is 5/8, because this was the 0.875 times 5/8, and that was 0.67 times 5/8, right? You get that. And then the top one was 1.5 times the diameter. We circumscribed it around our circle, right? So that's how you draw a polygon around a circle. So you can give it a certain size for the polygon.
So actually that's inscribed circle would serve a purpose because.
If you looked at a nut.
Because the bolt is.
Yes, it has a chamfer going around it.
chamfer, so-
And that's, so you see that
and
circle
that's-
there.
and that's it.
You bet. I was wishing I had a bolt here. But anyway, that's exactly it. I've got some big ones somewhere. I don't know where they are. Okay, now for the fun part. Let's draw this here. So right down here, we have some information that has to go on right here. Okay, now let me explain what this is doing here. They are trying to explain that. Okay, they explain, let's do the top of the thing because that explains it kind of orientated right. See those angles and everything? If we draw the nut, we have to invert that. And for you to learn how to do it, I'd rather have you follow this in the right orientation. So we're going to draw the head of the bolt. And then once you draw the head, then you'll see how it works and you can invert it for the bottom. Or else I'll show you even another shortcut if you want me to. Because if you draw all this is exactly the same. So all your angles and distances are going to be the same, aren't they? If you look at it. So what we're going to do, and we'll show you and you'll make sense. So we're going to come into this view right here. Okay? Now, these numbers are not 100% correct. Okay? Now you got to realize when bolts were drawn, they were drawn by a person that could draw on a drafting table with triangles. Okay? Because when they first started laying out all these books, you didn't have all these fancy adjustable triangles and everything else. You had a 30, 60, and a 45-degree triangle. That's all you had. That's all that was out there with the T-square, okay? So everything you see are going to be made off of those combinations of those triangles, okay? And I'll show you why it's off a little bit. Then I'll show you how we're going to tweak it a little bit to make it line right up, okay? So if you look at this drawing right here, you see that they come in from the sides here, from this side and from this side. They converge down here with a triangle coming down here like this, don't they? You see that outside triangle? We want to draw that. Now, the angle of that now is going to be a 30-degree angle from here. You know, from here coming down, well, it's going to be a negative 60 from this point here, right? And this is going to be a what?
Negative 30.
It would be a, yeah, okay. Or we can draw this one and we can mirror it, can't we? Does that make sense? So let's go ahead and draw that line.
If we intersect with the center, we don't have a center line.
But I can find the midpoint here and the midpoint here. I have two lines, don't I?
Yeah.
That's my mirror line.
Yeah, we can draw it.
We don't need to draw another line though. We have those two horizontal lines, right? And if I pick this point and this point, it constitutes the endpoints of a mirror line.
So AutoCAD is going to snap.
It's not going to draw a line, but it knows it's looking at those points. That's right. That's exactly right. So let's draw us a line. Let's go from here now. And let's go shift at maybe 2 or 3, shift less than negative 60, right? Just like that. Okay?
Well, we said 3, so it went all the way around.
Yeah. Okay, now, if you want to verify it, let's dimension that. But if you came out just slightly below here, you're just right. Okay? We know you're in the right place. Okay, now, let's mirror this line. Okay, so go to mirror, this line here, enter. There's a point and there's a point right there. So I just mirrored it without having a line. Okay, see how that worked? Because it's just asking for 2 points, right? And it doesn't have to be the endpoints of a line. It can be midpoints as long as the lines are parallel and the same length. We good there so far? Okay. Now we're about finished actually. What I want you to do at this point is I want you to take a line and draw from the intersection of these two right here and come straight up. Okay? Now, technically, I wouldn't have to do this. In fact, let's don't do it. Let's erase it. So I'm going to show you how to use another command. Okay? I want to draw a circle now from this point tangent to this line here, which would have been the intersection of that vertical center line, right? Same concept, right? I just want you to do it a little different way.
And that's where on the sheet, it says R for radius. but
Right.
It doesn't say what.
Right, but it's tangent to that line. Or if I drew a line, you could go from the intersection, but now we can go tangent to that line because we have our center point. See, I'm trying to show you a couple other ways of doing the same thing this sheet is drawing.
It's one of the arc commands.
So, let's just draw us a circle. So go to circle, center radius, right? Get center radius. This is your center point right here. Now, see, there's midpoint. That'll do it to us too, won't it? Midpoint.
Oh, so you just
So click right there. That's the same as tangent, isn't it? So if I didn't have midpoint turned on in my O-steps, I could have typed in TAN for tangent and would have given me the exact same circle. Or I could have done near. Near is going to give you the closest point from your center point to that line. And so there's three ways of getting that same exact circle with near, tangent, intersection. That's the other one. Whatever. You get what I'm talking about, right? Okay, good. Okay, now, what I want you to do is I want you to trim, and all we want is the arc from here to here. Okay? So let's pick this line and this line here and get rid of all that. So you just have that one arc right there. So pick that line. And that one there. Here. And pick this circle here. Okay. Okay, now, the other thing that they have on here now to do this, there's an arc here also, right? Okay, and this is where it's going to get off a little bit for you, and I'm going to show you how an easy way to fix it is. They're having you draw another line coming down here at this same angle here. How would be an easy way to get that point? Copy it over. You already have the right angle. Why we redo the @ command? So all I'm going to do is I'm going to copy this line here from that point right there to that point right there. Now, once I draw this, how can I get it on the other side? I can mirror it. Unless you want to do, So, let's come up here now. This becomes your new center point right here now. Let's go back into the circle, center radius, pick this point here and come up here. Now I can't say midpoint, but I can say TAN for tangent. See, there's my tangent point. Now, you see they don't line up right here. That's what I'm saying. They don't quite line up with these angles. Okay? That's where we're going to tweak it just a little bit.
In fact, it said something like deferred tangent.
Let's just click there.
Well, that's snapping to line. If I do TAN.
Yeah.
Deferred tangent.
Okay, now zoom in here. See, they don't connect up right there. You see where I'm looking at, where they don't line up? We want them to line up. Okay? So what we're going to do is we have to keep the same pseudo information on the other one. But I'm going to show you how to do this here now. So let's erase this one here. Or do you want me to do it on this other side so we have them both? We'll do it over here and show you how we're going to make it perfect, okay? Is that fair enough? Okay, so what I'm going to do is let's erase this line here to begin with. I'm going to draw a line now from this point straight over to here. Okay? So we have our endpoints here, right? Can I find this midpoint from here to here, up on this arc here now? If I have a line here, I could draw me a line from this midpoint here and up, right? Now, I'm going to draw me a 3-point arc, going from there to there to there. See how it's going to line up exactly now with our points? So instead of having some open lines, we're making them so they meet up exactly like that. Okay? So let's go to arc. We have let's see, start 3-point right there. You see it right from my eye. 3-point arc. Okay? So now, let's go 3-point arc. So here's 1 point. Here's a point. There's a point. There's your arc right there. That make sense how we did that? Now, this arc here now, that looks a heck of a lot better than that, doesn't it? Okay, so now what we're going to do is we're going to erase this here, this and this here. We can erase this here. I can erase that there too, can't I? And I'm going to mirror this over to here. So let's go to mirror, pick the arc, pick the arc, hit enter. Now, there's a midpoint and a midpoint. So we just copied it over there. Does that make sense so far? Pretty easy to follow these instructions now, is knowing this concept. Okay?
Well, I mean, we avoided the whole 30 degrees angle
And that's the hardest part of this. We'll get to that in just a minute.
instruction.
We'll get to that in just a minute. I'll show you how to do that. Okay? Now, I want you to trim out these little lines right here. Okay? Because you think about it, if you have a head and you cut a 30-degree angle around that head, those lines are going to disappear, aren't they? Going around there.
So
Okay.
The corners.
Now the corners we have to do yeah, we got to work on that now. I'm just taking care of the center. Now we're going to do our edge. Okay. Now can you see how you could do the bottom of the nut now? You just have to go up this way instead of having that first coming down this way, don't you? Exactly the same way. Okay.
Well, the nut is just as wide as the.
Right, exactly. But your angle is
They
going
added
to
the bolt,
come
so
from
we
here like this here.
Yeah, but we can. I mean, the arcs we can just mirror them.
Exactly. Or you could copy, rotate, and move it down. Either way you want to do it. Yeah. We could mirror, but we still have to move it, wouldn't we?
Right, because we wouldn't.
We don't know. Now, we could find that distance if we wanted to. If really bad, we could draw a line. We got our midpoint, don't we? Okay. Are you starting to see how you can draw additional lines to find things? Did everyone understand what we were just saying? If we drew a line from here down to here, I could mirror this right in place by drawing if we drew a line here, picked a midpoint and came over here and picked another point with my ortho on, I could do it that way too. Okay? So again, there's numerous ways of drawing it once you understand the basic concept of getting it down there. Okay? Okay, now what were we going to do? Oh, 30s, sorry. Okay. I'm going to draw this one here first, so since it's just a little bit easier to draw, because our angle is going to be a 30-degree angle. Okay? So, to draw this angle here now, this is where you have to kind of pay close attention to also. I'm going to draw a line starting tangent to this line at an angle. I'm going to use my at command. Okay, but where's my first point going to be? Tangent to that arc, not pick a point. Because whenever you use the at command, you've been able to pick a hard point first, right? But all we're doing is picking tangent now first, and so our line can move depending upon the angle. Okay, so to prove that now, let's go ahead and use the at command. So I'm going to draw a line. The first point, I want you to type in TAN for tangent. And then pick this arc right here. Now look, as I move my cursor around right there, what's happening to my point of tangency? It's moving, isn't it? Okay. Okay. So in the line command, and type in TAN. Then pick this here. Now see, as I move that, see, now I can give it an angle, a length at an angle. So I'm going to go shift at, maybe 1, shift less than 30 degrees, right there. There's that chamfer angle. That's that 30-degree angle on the end of your head there. So that's where you get the circle basically right there, isn't it? Where you cut that around. Okay? You can, yes. Yes, you can. So let's finish it, okay? So I'm going to trim it off now. And then on this line here now, I got to get rid of this here. Okay, now, question for you. You notice this line doesn't go all the way down to here, does it? If you put your cursor over there, see it stops about right there? Okay, so we need to extend this line down here. Just think about it. If you start a chamfer on it, that's going to be a straight line, that whole chamfer, isn't it? It's not going to come down and then have a little arc on the bottom of it. It's a chamfer. Okay, so let's extend. I'm going to extend it to this line right here, this line here. Okay, that makes sense? Now, again, this is so slightly. I mean, this distance from here to here is ever so slightly. So we're going to trim it off. I'm going to pick that right there and just get rid of that little bit right there. And then I'm going to pick my line here and get rid of that there. And that's the end of, that's how you're into your nutting. So you're going to trim off this, pick the outside line, That one, whoops, hit escape. Undo. You trim. I'll pick this first line here. No, don't. You got an extra click there. PR for trim. Enter. Pick this line here. Enter. Now pick this line here. That's the one to do that. See, that's that arc. And when we put a chamfer on that, we want again, it's not 100% extrude because the instructions are for triangles. Okay? Now trim off this little section here. You trim off the bottom one because it's the arc, because if you put a chamfer, you want that to be a straight line. That's part of that precision, you know, with the triangles. Now we got to get that same thing over here, right? But yes, yes. We're just going to mirror this line here, aren't we? And then trim things up to it. So we're going to mirror this line here. We're going to come over here to our midpoints there. And there it is, right over there. And now we can pick this here, and we can get this out of here. And pick this, whoops. Undo. Get rid of that there. So there's the head of that bolt right there. Now, do you want me to show you the easy way to do it? Do this one here. Okay, what I want you to do is to draw a line now from the midpoint there down to the midpoint here. Okay? Now, let's come up here. I'm going to go to mirror. Now, this is really critical. I want you to watch this now. I've got to pick that angled line, the arc, this arc here, that line, and that line right there, don't I? They're what I want to mirror down there, right? Okay, so first of all, I'm going to erase this line here. Because I've got that line built into this line here, don't I? Now watch this. When I go to mirror now, if I come here, what lines is it accepting right now? Well, be careful now. Be careful. What lines is it going to mirror right now, or arcs? How many? One. Don't I want it to have 1, 2, 3, 4, 5, like 6 of them? How do I get all 6 of them now? Now, watch this. This is something that'll really help everybody. Let me go through this again. We go to mirror. Okay, yes, exactly right. If I come from here now, come here, see, I only have 1. But, well, I have 2, I'm sorry. I have the chamfer and the 1 arc, don't I? But they are completely encompassed in this rectangle box. Now think, I drew that from the left to the right, correct? Let's see what happens if I go from the right to the left. Okay? So, if we mirror now, and if I go from here over to here now, what lines is it picking up? Everything that touches or a little segment is inside that rectangle. So it depends on how you draw your rectangle, if you want to have it completely enclosed in or just a little segment of it. So when you guys see me doing my center lines, when I trim and copy and so forth, I'm just doing this right here where I'm picking all of them at once. And I don't want to pick the circle. I just go from the right to the left and build a little rectangle inside that circle. And I only have to have a little segment touching that box. That's how it, yeah. I ruined it for me, didn't I?
No, I'm just kidding.
But you understand what it is now, right? So it's good to know. So I can come clear over now, but look what happens now. See, it's going to mirror these other lines too, and I don't want that, right? So I'm going to go back and mirror, and I'm gonna build a point right there, because those are the ones I want, aren't they? So I'll click that, hit enter, and there's my midpoint right there of that line, isn't it? Click there, just come out here and click any point right there, erase. Now, sometimes you'll mirror and it just won't do it. But look at that, that's one step a lot of students forget, where it says erase source objects. You don't want to erase your source objects. But sometimes if it erases it, this is where you have to change it to go back to keep them. Is that okay? And then just click enter. And guess what you got here now? Now you just have a little trim and you got it, right? So now you could trim and you could actually do this right here and get everything, couldn't you? That make sense? Oh. That's what we wanted to draw right there. Now we'll draw the thread in here. Now, do you think you can do the 1/2 inch one after this? Should be able to, shouldn't you?
Like I said, as long as you don't make me.
I wonder if you could just scale it. I haven't done it that way. But think about it. What's the scale factor from a 1/2 inch to 5/8?
Well, see, that's what I was thinking is creating this into a W block and like you say, scale or something.
Yeah, but you can just make a copy and scale it right there. But now think about it. What's your scale
W
factor?
block,
And we'll
use
try it.
between drawings.
We'll try it. Now think about it now. We're at 5/8. We want to go down to 1/2 inch. Can we be greater than 1? It'd have to be the other way. You have two numbers, right? You want the smaller number of the two. You have 1/2 inch and 5/8. And it depends which way you divide. You get 1 greater than 1, 1 less than 1, right? And so 0.8 now, does it extend out or does it terminate? Even? Good. So we'll try that after we do our thread. Is that okay? Okay. So now, what's the thread on this? This is a 5/8. It's a 5/8 what? How many threads per inch? Did you cite 16 on your main drawing?
Oh, the main drawing.
Yeah. So it is 11. So 11 threads per inch, right? So my pitch is 1/11, right? Okay, so what's half of 1/11? So let's offset this line up 1/22. That makes sense? Offset 1/22. Right to there. Okay? Now, question for you. If you have this nut going into this bolt, going into this nut, what angle do you want your threads going?
Well, at the very end, it's 45 degrees. Right?
No, the angle, your lead angle here.
Oh,
If I have my line going from here to here now, will it turn to what? Yeah. So do we want it from here to here then? Okay, that makes sense. So let's draw us a line now. That's the angle of your thread right there. Okay? Now erase this line. You don't need this line anymore. The only reason you drew that line was to get that point so you could draw a line for your angle, right? That's the only reason we drew it for.
So now we do the array command.
Now we do the array command for about 3 times. Okay, we're going to get one complete thread, then we're going to array that thread 11 times, right? Because we're threading 1 inch, right? So let's do the array. Take this line here.
And Mike, once again, there was a trick. It's not the rectangular array we're doing.
It is the rectangular array. We can't use the offset. The offset will go off on a slight little angle. It'll follow that angle of that line.
That's what I remember having.
Right. We need to do an array because the array is going to be columns and rows. It's horizontal and vertical. Okay. Okay, so we do an array here. We're going to do a rectangular array of this right here. Now, question, how many rows do I want? 3. How many columns do I want? 1. Does that make sense? Do you see the difference between rows and columns? So we don't want these others over here, do we? So we want 1 column. Did you draw it up before? You're okay with this though, are you?
I think I can figure it out.
Okay. So columns right here, let's change that to 1. You can leave the rows at 3 to begin with. Okay. Now, what is my distance? Am I going to put this distance here in or this distance over here? I want the rows, right? Because they only have 1 column, don't I? Now, is it going to be a positive or a negative number? Positive number because it's going up, right? If this was going down, I'd have to hit a positive to reverse the order, or a negative. Does that make sense? And then what do we want this number here to be now? 1/11. Very good. That's my pitch, right? So 1/11, right there. And just hit enter. And it'll put it right like that. Now, question for you. How do I know this is right? This distance right here is half my pitch, isn't it? So this should be approximately half of that distance right there, isn't it? And it looks like it's half, right? So if it was the same distance, we'd know we did something wrong, right? That's how you tell, am I in the ballpark? Am I right? Am I wrong? Whatever. Okay? Okay, now, if I touch right here, how many entities is that? What do I have to do? I have to explode it right there. Right under the pencil is explode, and then just pick on here. Okay? Now, we've always drawn our threads from right to left or left from right now, right? Now we can go top to bottom, right? So, but the angle's the same, isn't it? The question, if I come here, and if I draw a 30-degree line up here, what's that angle going to be? It's 30 degrees off of here less. 150, yes. So I'm going to draw a line from here now at 150 degrees, 150. So let's draw us a line now from here. And go shift that, maybe 1, shift less than 150. Right like that. Okay. What's this angle going to be here? Okay, that's a positive 210, right? What's your negative angle? Nope.
Oh, we're doing 60s.
You make it too hard on you. What was this angle here? 30. Negative what? Now think about it. This here was from here to here.
That was 150.
Negative 150, wouldn't it be?
Oh,
Does that make sense?
not really.
Because look, if I drew a line right here, I have to come down here 30 degrees, right? I have to come from here around to that 30. So it's a negative 150.
It's like you're flipping the coordinate system.
Exactly. We're kind of doing that. But I can go positive and negative. And if I have 30 up here and 30 down here, what angle do I have between them? 60. Okay? So let's draw us a line now from this point here now, and go shift at 1, shift less than a negative 150. Okay? There's your B right there. I'm going to do a fillet, make sure my radius is 0, and trim those two up right there. Okay? Very good. Now, how do I get these right here? Copy. Let's copy. I'm going to copy this one here from that endpoint here, which goes right to here, right? And then this one here, which this endpoint goes right to there. Now what I can do is I can draw me a line from the root of my teeth right there. Okay. Now, as I array this, my pitch, remember, if I do this and this line here, it'll put me a double line right here, won't it? So I've got to do a little erasing now, don't I? I want to get rid of that line and that line there. So as I do an array of this at 1/11, this line is going to be right there, be the exact angle right there, but I'm only going to have one line on top of each other, aren't I? So now let's do us an array. Come on here, array here, we'll do a rectangular array. Now I'm going to start from right to left. See how I'm doing that right there? That's all I've been doing. That's what I do every time I draw it. I try not to pick them individually. Use that box. And you know how a box works now, right? It'll take a little while to get used to it, but it'll speed you up too. Okay, so I'm going to go to there and then hit enter. Now I want, how many rows do I want?
So 11 per inch, and we're doing 2 inches. So
One
it's
inch,
1
1 inch of it, 1 inch.
We're doing 1 inch.
Yep.
So 11.
So 11. How many columns do I want? 1. What's the distance between my rows here? 1/11. Right there. And then just hit enter. And guess what? Your thread is drawn on your bolt right there. And then I'll help you put the chamfer on it. Okay? So what I can do now is I'm going to trim. I'm going to pick that one line right there. I'm going to get rid of this line here and that line there. And I'm going to just erase this line here. Well, I'm going to trim this line. See why I'm trimming it?
Yeah.
If you don't zoom in, you say, well, I'm just going to cut it off to there. Okay? So we're going to trim. I'm going to pick this line right here and get rid of oh yeah, thank you. Remember, it's one entity here. Thank you. Pick that right there, explode it. Now we can trim it. So there's that. Now the only thing we have left now is put this chamfer on the end here. Now let me ask you a question. Knowing this now, are nuts and bolts pretty easy to draw? They aren't too bad, are they? But if you, as far as you understand, there's two multiplications you have to do, right? To get the diameter of the head and the height of the head, well, three, and the height of the head and height of the nut, right? And so, okay. So, how do I find where to come from to start my 45 coming here? The root right there. There's my start point right there, isn't it? Right there. Now, what's my angle going to be here now? 45, isn't it coming this way? Isn't that 45? 135, yes. You see how you can start working with angles? You start getting used to angles, how they're referenced. So let's go ahead now and draw a line from here back at 135. So draw a line from this point right here and go shift at maybe one shift less than 135. What did I do wrong? Okay, draw a line here, shift at one shift less than 135. There we go. Okay. Now remember, that's a chamfer cutter. You put on the end of the bolt, and you're going to run that cutter in on your bolt right here, so it's going to take that off, that first thread off like that. Does that make sense? And it comes in like that. So we can hit the fillet command, and I'm going to go from there to there. We don't need this line here anymore. I can trim off this line here, right? Because I don't have it anymore after I run my chamfer cutter in, right? Now, this line right here is going to change depending upon how far we run our chamfer in. So what do I have to do over here now? Now from these bottom lines here, straight down, draw a line from here now. What's this angle here going to be? 45. So shift at one, shift less than 45. Now see, there's that truth here now. I'm going to do a fillet width right to there. So if you looked at this, that first thread now is shorter than these other threads right here, right? So it's helping you line it up and to kind of get it so you don't cross thread. Now, you can still cross thread, don't get me wrong. You can still get it cross threaded. But your chances are better not of getting it cross threaded. Okay? Has anyone got cross threaded bolts and nuts before? We all have, haven't we? Okay. Okay, now, you know, it was so interesting because we were doing some of that spray insulation, that white stuff that never comes off you once it gets on you. And it expands, and if you get it on your clothes, it's permanent on your clothes. I didn't want to do that up on this cabin, and so there were a bunch of teenagers that thought they knew it all. And so I let them go ahead and spray all the windows and doors. And their mother came and really got after them because they weren't doing a very good job, because their grandpa actually told them, that's not a good job. Well, I gave their mothers a spray can the other day, and they said, this is a lot harder than I think it is. They said, we don't have to make it look pretty, do we? They just slapped it on. They didn't have to do the windows and doors. They did kind of a cold air return for me. Just slapped it on. It bulged out, and it was ugly, and but it filled it. It filled it. Yeah. So all we have to do now here is erase this line here, trim out this line here now. And what do I have to add now? A line from the tip to the tip. Just like that. And that is how you do nuts and bolts. That's a nut and a bolt and the thread. That's your 5/8. Okay. Now, let's see if we can scale it. Shouldn't even let you do that, should I? Then you won't have to redraw it. But wouldn't it be nice to know if it worked? Because if it worked, what would you do? You would say one nut, right? And you document what it is, and then you get in and do any other nut, and you find that scale factor, and bingo, your nut's all finished. You never ever have to do it again. That's right. Now, but now, the thing that I hope you don't do is you don't forget how to draw one if you ever have to. And that's why a lot of times, when we do things, I'll eventually show you how to do it easier. But I like you to go through and struggle through it a few times. A student was talking to me this morning. But one of the things I enjoy doing is I really enjoy watching students struggle. Because they're at least trying. They're finding out, their own questions. Why doesn't this work? Why doesn't this work? Then you do it and they, oh, that's why it doesn't work. But if you just watch me do it, do you ever get those questions and say, well, that doesn't work. How do you fix that? Does that make sense? Exactly. Learn from your mistakes. And so that's why a lot of times I want you to go through, and I'll purposely let you go through and make mistakes and let you struggle with it just a little bit. Then we'll come back and we'll fix it and go from there. So that's how I feel. I learned anyway. So hopefully, did that help you out on this though? Was it plain enough to help you so you know what to do? So now you should be able to finish up that assembly, shouldn't you? You don't need that cotter pin in there. Why do you think they have a cotter pin on the end of that nut?
Sliding off.
To what?
Keep it from sliding off.
Okay, but how does it keep it from sliding off? That hole goes through the nut and the bolt. And you stick a pin through there and it won't turn. So it's like Loctite. You put Loctite on there also, but you can always break Loctite apart if you need to. So if you're riding roller coasters, I know for sure that on roller coasters, they don't just put Loctite on there because the vibration would work way loose. They put nuts, and then they put holes through there, and they put a wire through there to hold that nut from keep rotating. Now, as you design something though, let me ask.
Rivets.
What?
Could have done a rivet instead.
Okay, let me talk to you about that. Let me talk to you about this. Just happened this last weekend. I was talking to a guy, and he is in charge of the biking club in one of the high schools. And so he has his bike rack, Yakima, a really nice bike rack. I mean, he paid a lot of money for that bike rack. Well, he had 4 bikes on it of kids on the biking club. This one kid, his dad's very well to do. His bike was $13,000. Well, he puts it on this bike rack, and they go up to, they were going up to Beaver Mountain, and they got off the road. Actually, they were going up to White Pine and biking down, or somewhere up, anyway, up from there. And they went over bounce, and guess what happened? that $13,000 bike fell off. And, I mean, it
That's why
demolished
that's why I
the
have
bike.
Kool-Aid, not the actual.
What? And so, but Yakima is supposed to be a good one.
I'm just joking.
I know. I wouldn't carry any other's bike anyway. But the guy,
Well, and there are different ways to attach. Some of them you take off the front wheel. And you
yeah, but this one, just by going over the vibrations with rivets, that's why, you know, it broke those apart and tore that whole rack apart, and the rack fell apart, and that's what demolished the bike. And, you know, when you have a carbon filled, you know,
Well, he had,
so thin,
he had
you know, and
an insurance,
everything.
he had an insurance on it.
No, he didn't.
For $13,000,
I guess
you don't get an
insuring bikes, like, except for motorbike, it's hard to get.
Strange.
That's what I found out over the weekend. So, yeah, kind of fun, kind of a bad weekend for him. So, you know, just be aware as you start designing things. Because what I really want you to do is when you get out of here and get a job, you know, I want you to be able to know these things so when you start in designing things, and when you go and have a senior engineer design something, and you come ahead and start questioning some of the things, you know, how do you think your credibility is going to move up? If you start questioning and it saves him the embarrassment of having a failure, you're going to go sky high, aren't you? If you get him to correct something.
Well, I guess it all depends on how you question.
Yeah, I mean, you can do it in a
Arrogant
way, and then it goes down.
That's
But if you do it on a,
respectfully.
you know, respecting him and say, you know, can we look at maybe, you know, this? Is there a stress point here that might break here?
Kind of how I try with you.
Yeah.
Say, Mike, what do you think about this? You also
I don't know about that one. You do that after you leave the meeting, you know, in your small little groups, you know, because it's interesting, you know, the more education you have, the smarter you are, right? The smarter you think you are, right? Yes.
I mean, you are somewhat smarter, but education is mostly demonstrating that you're trainable.
Right. That's exactly right. But anyway, it's something you need to kind of know how things work, you know, but don't, you know, and this was a weld joint, and weld joints are supposed to be a lot stronger, right? But, you know, just that weight and that flexing, going over a bump, you know, with the 4 bikes on the back of that rack. Yeah.
Well, actually, they can probably sue and say this rack wasn't designed.
They have disclaimers. It's like, you know, you go on, you know, the legal things, you know, with every. Have you ever wondered why every medicine has all these side effects listed onto it? I mean, if it ever happened or ever thought of happening, they got to list it to safeguard themselves.
So that's part of why medical insurance in the U.S. is so high because of the what are they called? Malpractice lawsuits.
Yeah. Yep. Kind of sad.
I mean, my father died of cancer in Soviet Union. We didn't have malpractice lawsuits. They misdiagnosed him for 4 months. We could have sued, but that doesn't exist. That didn't exist there.
Yeah. Okay. So for the what? Oh, we just made that.
Oh, you just.
Yeah, we randomly made that too. So
I think I could finish it.
Yeah, we did all that, right? Oh, okay, yeah.
I'm gonna go on that.
Oh. And I could get one in here now to redraw it, not the whole. Oh, but they aren't gonna do it. Yeah.
You know, I'm not a very high speed CEOs.
Your threads might be different. That's the one thing. Yeah. Exactly. Yeah. Yeah. The thread might be a different thread. Yeah.
So I don't know why I signed up for
That
it.
was scaled ahead, this.
I tried to go through it and see if I could more.
The problem is,